Te lo voy a mandar otra vez, ¿vale? A ver si este funciona. Ya está. Sí. Okay, I see 3 people. I don't really know what happened with the connection. Okay, so I think I'm going to start. Sima, you're asking me, how can I connect? I hope that you can see me now. Okay, all right, I'm going to start with the explanation, all right? So, as I was telling you, today we're going to learn about electrical circuits, all right? So, we go to Electroland, and the last mission that I created, that is electrical circuits. Okay. In the story of the objective, you have a virtual presentation. So you click here on the link in virtual presentation, all right? And this presentation should open electrical circuits, all right? So we're going to learn the basic concepts, okay? What is an electrical circuit? What elements make a circuit? And how the circuits work, all right? So the first thing is, what is a circuit? Basically, as the definition says, a circuit is a path or a line through which an electrical current flows, all right? And here we see, okay, a basic scheme, okay? So it's basically a path, all right, that starts in the battery through which the electricity flows, all right? The second idea we need to understand, all right, is how the circuit works, okay? Here we have the diagram of a basic circuit, all right? And it includes, we can say, 3 different parts, all right, in general. We have the source of energy, which is the place from which the energy is generated, all right? And this source of energy, it can be a battery, a generator, it can be a solar panel. We'll see later different examples. So the source of energy is the place where the energy is stored and or generated, and it's sent to the circuit. Okay, so the electricity is going to circulate, to flow through the wires. Okay, which is the connection. Okay, this green part is the wire, all right? Usually a wire, it's made of copper, okay, which is a metal and it's a good conductor, and it has got an insulator surrounding the metal, because otherwise if we touch the copper while the circuit is functioning, we will receive a shock, all right? So this is the second part, okay? The source of energy, the connection. Here, this part is the switch, okay? A switch is an instrument that we use to let the current flow or no. So we can open or close the circuit with the switch, okay? It's the same, for example, when we switch on the lamps at home or a light, okay? We switch it on or off. What we're doing when we switch on and off the lights is closing the circuit or opening the circuit, all right? And the third part, it's the output device. Here we have a light bulb, okay, or a lamp. But the output device, it can be other things. For example, it can be any electrical machine that we have at home, like the television, a computer, it can be a toaster, the refrigerator, any electrical device, all right? Or it can even be a fan, for example, okay? In summer, when it's really hot, we might use a fan to move the air and refresh the atmosphere. So these are the three basic elements: the source of energy, the connection elements, and the output device. Now, let's see how the circuit works, okay? If we compare these two pictures, okay, we can see that one circuit is opened, all right, because the switch is not closing the circuit, and another circuit is closed, all right? So this one, we can call it, okay, an incomplete circuit, because since the switch is open, the current, okay, cannot flow through the whole circuit. It's going to be interrupted here, all right? So this can be called incomplete circuit or an open circuit. And here we have a complete circuit. You can see that this switch is closed, which implies that the current is flowing through the whole circuit, all right? Let's continue. Now, here we have different symbols that are used to represent the elements in the circuit, all right? I put the names in Spanish and in English because next year, since we have the Comunidad de Madrid evaluation at the end of the course, okay, they include sometimes exercises related to electrical circuits, and it's a Spanish test. So I want you to know both the concepts in Spanish and in English, okay? This symbol here represents pila, okay, or batería, or generador, it can also be called, all right, which in English will be battery, generator, or source of energy, fuente de energía, all right. The second element we can name is the interruptor, or switch in English, that it's opening or closing the circuit. Then we have the cable conductor, or wire in English, which is just the line, all right? Bombilla, or light bulb in English, that is represented with a circle and an X or a cross in the middle. And also another output device, instead of a light bulb, it can be a motor, okay? To move, for example, a fan, all right? Which in English will be engine, all right? So these are the basic elements we have in the circuit, and these are the symbols that are used to represent all of them, all right? Now, if you remember this, we talked about these two concepts, insulators and conductors, when we talked the other day about static electricity, okay? Remember that insulators are materials that don't allow the electricity to flow, and we have here some examples such as rubber, glass, oil, diamonds, or dry wood, okay? You say, Laura, why dry wood? Okay, because wood, if it's wet, okay, it implies that contains water. And we can see here that water is a good electrical conductor. So if we want to use an insulator material, we should use dry wood, okay, never wet wood that contains water. And conductors are elements that allow the electricity to flow through them. Remember that all the metals, okay, are conductors. Some metals are better conductors than others, all right? So some examples could be silver, gold, copper, steel, and don't forget that water is also a good conductor. And seawater will be a better conductor than fresh water, because seawater contains salt, okay, that is formed by chlorine and sodium, all right? So these two elements are good conductors. That's why seawater is a better conductor than fresh water. Okay, we're jumping now to the next point. Different types of sources. If you remember, okay, we talked about the source of energy, okay, the part of the circuit that generates the electricity. And we can have different types of sources. We can have cells, okay, like pilas, they're called cells in English. You can also have batteries, like the ones we have in the mobile phones, lithium batteries. We can also have electrical generators, or why not? If we talk about wind energy, okay, so we can have the wind generators or solar panels. And this thing here, I bet that most of you have never seen this before, but if some of your parents are watching this video, they will recognize what this is, okay? This is called a dynamo, okay? A dynamo is an electrical generator, okay, of energy that was used in old bikes to light the light bulb, the frontal light bulb that old bicycles had, all right? This is basically a system in which this element, the dynamo, was next to the tire of the bicycle, and the movement of the bicycle, of the tire, will make that this, okay, cylindrical part here to move. And this movement, that is mechanical energy, will be transformed into electricity to light the light bulb in the bicycle. All right, so these are some examples of types of sources that produce the electricity in the circuit. And the next point we're talking about is the types of output devices. Okay, remember here the generator, okay, the source of energy, the connection, and the output device. So instead of using a light bulb, other output devices could be maybe an elevator or a lift, the television, a fan, a toaster, all right? Any machine that requires electricity to work, all right? So this is the theoretical explanation, all right? Now, if we go to Tarea, all right, and you click here in book, I highlighted the information, all right, in the book. The definition of an electrical circuit is basically, okay, what allows electrons to flow through a path, all right? Remember when we talk about static electricity that we said that electrons are the part of the atoms that can move from one atom to another. So when we talk about electrical current, we're talking about electrons moving, all right? So in this diagram or in this scheme, we have the parts that we talk now about in the presentation. We have the power source, all right? Or as it's called in the presentation, okay? The source of energy, which is the same thing, all right? In Spanish, we can call it generador, and it can be a cell, a battery, a generator, a wind generator also, a turbine, all right? The function of the power source is to provide electrical energy to the circuit. Then we have the wire, okay, that conducts electricity, cable or conductor. The resistor, okay, which is the receptor or resistencia, or what in the presentation is called output device, okay? So this transforms electricity into other forms of energy, all right? An example is the light bulb. And here we have the switch, okay, interruptor, that opens and closes the circuit, okay? So it can let the current to flow, or it can interrupt the flow of the electrons, of the electricity, all right? Okay. So, since we explained these concepts, you can continue doing the competence photocopy exercises 7 and 8, all right? And I will send you the solutions next Monday, the 23rd of March. Okay, dokie? So, today, after watching the video, the presentation, highlighting the information in the book, reading everything and understanding all the concepts, you can start with the simulation laboratory, okay? Today I just want you to do a free practice to get familiar with the buttons, the application, how it works and everything. So here we go, okay? You click here and the application is opening. Here it is, and we go to intro. All right, so different things that we have here. All right, here you have options that you can activate or not, all right? Show current, so here is where we're going to see how the electrical current flows, and we have two models, the model of electrons and the conventional one. I want you to use this one, okay, the electrons model. We're not paying attention to the voltmeter and the ammeter, all right, because these are concepts that we'll see next year. And here you have two types of diagrams. This will be the representation with the real objects, and this will be the representation with the symbols that I explained you, okay, here in the presentation. All right, so we're going to see both models at the same time. Okay, so how to build an electrical circuit? All right, the first thing we need is a power source. Okay, we're using a cell here, and then we need wire. Okay, so we need to create a connection. All right, it is important that when you are creating the circuit, you use, all right, or you put the two red parts together, one over the other, so the connection, okay, is effective. All right, if by any chance you make a mistake and you say, oh no, I didn't want to put this here, what you have to do, for example, oh, I don't want this wire, you click on the wire and you just delete it, all right, and you can put a new one here. Or if you want to change some part of the circuit, instead of deleting everything, what you can do is by clicking on the connection points, okay, you can just cut it, all right, and restart the construction of the circuit. All right, so I'm going to build a basic circuit, okay. We have the battery, all right, wire here, okay. I'm going to add another part like this, and I'm going to introduce the switch. Okay, here is where you have all the elements, the wire, the battery, a light bulb, the resistor. Okay, I'm not talking about this concept yet. You have also fuse that I'm not talking about, and here you have different objects or elements that we can introduce in the circuit to see what happens. Okay, but for the moment we're just building a basic circuit. All right, so we need the battery, the wire. Now I'm going to add a switch here. Okay, that's it. All right, some more wire. And I'm going to include the light bulb. All right. Okay. So this is the basic circuit with all the elements, okay, that we know. The power source, all right, which is a cell now, the wire, the switch, and the light bulb. As we said in the theoretical explanation, the switch, what allows us is to close or open the circuit. Now you can see that the circuit is opened, all right? So the electricity is not flowing because the current is interrupted in this part, okay? So the switch doesn't allow the current to continue. That's why the light bulb is not functioning. If I close the circuit by clicking here in the gray circle, I close the circuit, okay, so all the current is flowing and it's making the light bulb to illuminate, all right, the circuit. All right, if I click again, the circuit is open, so the electricity is not flowing. Now, with this same circuit, okay, this is the real representation, what the circuit will look like, but on a paper, we will represent this circuit with symbols, all right? I'm going to, okay, hide the electrons. So here you can see this is the power source symbol, all right? The video stopped, says Sukaina, and I think it's continuing. One moment, I'm going to answer Sukaina. I think it's working, yes? That everybody's watching it, yes. All right, so as I was explaining, okay, this is the representation that we will draw on a paper, okay? So this is the symbol for the power source, all right? Here you say the pila, all right? The lines, okay, straight lines will be for the wires. That's it. Here we have the switched. As you can see, it's the same symbol. And here we have the light bulb, all right? In this case, it's not the same symbol, all right, here in the application, but the real symbol you should use will be this one, okay? A circle with a cross in the middle. All right, let's go back to this. All right, so now imagine that you have this simple circuit, okay? You made a model at school, and we have a problem. One of the groups that is working and creating a model of a circuit runs out of wire and says, Laura, we have a problem. We've run out of wire and we cannot close the circuit. What can we do? And I give you different options, okay? So what I'm doing here is, okay, cutting this wire and deleting it. All right. So you say, Laura, what can we do? We cannot close this circuit. So I give you different options. I tell you, all right, guys, you have got these materials here, okay? You've got a pencil, you've got an eraser, you've got a coin, and you have a paper clip. What materials could you use to close the circuit? And someone tells me, oh, I want the note, I want the money. Can you give me that dollar, please? And I say, oh, yes, absolutely, you can have it. So what we're doing is trying to connect, okay, the circuit with the dollar. We close it, but we see that the light bulb is not lighting. So we can understand that the note is not a good conductor, okay? So I'm going to try it with another one. For example, the paper clip. What do you think? Is it working, not? Remember what we learned about the materials. Insulator materials and conductors. All right. So a clip is made of metal and it makes the circuit works because metals are good conductors, all right? Let's try with the coin. What do you think? Will the coin work? Let's see. It works, and it's obviously because the coin is made of metal. Let's try it with an eraser. It doesn't work because, as we said, okay, rubber, okay, which is the material of the eraser, is not a good conductor. And what about a pencil? Do you think, will it work or not? Okay, let's see. Hey, you can see that the light bulb is lighting just a little bit, okay? And this is because the pencil has got graphite, okay? So it's made of graphito. And this is a material that conducts electricity, but not very well, all right? That's why the light bulb is just lighting a little bit. And what about, for example, a human hand? Well, it's probable that you heard that humans, okay, or living things conduct electricity. And it's true. We conduct electricity because our body is made of water. And remember that water, okay, 75% of our body approximately is water. And water is a good conductor. But if we want to see this effect, okay, that the human hand will connect the circuit, what we will need will be a bigger battery. Because our body is, it resists, okay, to the pass of electricity. So these type of batteries are very small to let the current flow through our body. If we wanted this to be effective, to be real, okay, what we should put here will be a bigger battery. All right, that's why in this model this is not working. All right, so these are the basic concepts I want you to understand. Okay, now okay, see 7 people. Okay. The explanation will be finished, okay, right now. So what I want you to do now, if you can, because I don't really know, if you have any questions, doubts that you would like to ask me before closing the broadcasting of the video, maybe you could type them here on the chat, okay, here where I am writing. Here you can send me your questions or doubts. I'm waiting some time to see if you have any questions. I don't really know if this is working, all right? If it doesn't work, we have an alternative, all right? Any questions or doubts that you want to ask me, in Classcraft, you can go to Mensajeria, okay, to the speech bubble, and you can send me your questions here. I see that Sima sent me a message saying, Laura, the video stops sometimes. Yes, I know. I think it's because of the internet connection. Because these days there are a lot of people connected to the internet, so this is affecting this kind of connections. All right, so any questions you have, you can ask me through Classcraft, all right, or here in the video chat. All right, I don't see any questions. So I think this is because you haven't got any doubts or questions, or maybe because the chat is not working. So I'm going to cut the emission, all right? Have a nice weekend, all right? You can continue doing the activities that I gave you during these days if you still haven't finished all of them. And I'll see you next Monday, all right? Take care, be happy, don't frustrate a lot for being indoors all the time, be patient, all right? But I'm sure that you're enjoying somehow all this time with your families, all right? Bye-bye, see you next week.